Once you have started using the Linux command line tools, you'll find that sometimes you have to complete some tasks routinely by repeating lots of commands. Um, so this is not very efficient if you have to type lots of commands at the prompt in a terminal. Sometimes you would like to group those commands together into a file, and every time you have to complete a certain task, you just execute that file, and all the commands inside of that file can be completed automatically. So uh, essentially this is about how to write shell scripts. So in principle, the shell scripts is just like a computer program. You can build quite complicated logic into a script, and you can store variables inside of the script, and it will function just like an ordinary computer program, except that lots of the commands that's sort of available in the command line system are also available inside your shell script. So now let's try to learn how to write shell scripts. So shell scripts is just a basic way for you to sort of group together lots of command line commands into a file. So it will sort of save you typing, and it will sort of automate lots of tasks, and it will allow you to build lots of complicated logic into your program or into your task. So how do we actually write a shell script? Let's start by doing a very simple example. Let's write a very simple script. I'm gonna use the Emacs editor without the window. I'm, I'm gonna call my script script1.sh. So a shell script is gonna be executed by a certain shell, and Linux actually has quite a few shell that's automatically installed and or commonly available. But the one that's sort of most common and the one that's used most widely is called bash, B-A-S-H. So if you type which bash, it's going to tell you that bash is installed under bin. So this is sort of the default shell every time you log into, for example, Ubuntu operating system. So and on many other Linux distributions, bash is sort of the default shell. And uh, and uh, and let's look at how we can actually write a bash shell script. So let's use Emacs editor without the window, without the graphic window. I'm gonna call my script script1.sh. So if you are writing a bash script, you can use the extension .sh, and it's gonna indicate that it's a bash shell script. So I'm gonna just put one command into it. I'm gonna just use echo hello world. So if you execute this particular line on the command line, after the terminal prompt, it's gonna display hello world in the terminal. If I wanna save it, I'm gonna do Control XS, and it's Control XS. Hold down the Control key, type X and S without releasing the Control key, typing X and S, and then it's gonna save it. So if you look at the script one, it has just one line in it. Of course, you can execute this command just inside of the terminal after the prompt, and then it's gonna display hello world on the terminal. But now you have a shell script. Even though this shell script has just one line in it, it's still a shell script. And how you can actually execute a shell script? You can do that by calling the shell itself, bash, and then followed by the script name. And then it's gonna give you exactly the same effect, just like executing echo hello world in the terminal after the prompt. It's having exactly the same effect. It's gonna display hello world, but this time you're actually putting the command into a shell script, and then you're executing the shell script by calling bash, and then script1.sh. That's one way of executing a shell script. there are several different ways of executing the shell script. So suppose you don't like typing bash every time you execute a shell script. If you would like to save some typing uh, during executing the script, you can modify your script by adding a line at the beginning. It has to be the first line inside of any shell script. It's called the Shibian line. A Shibian line starts with two symbols: the sharp symbol or the pound sign. That's this particular symbol, and then exclamation mark. And in shell scripting language, an exclamation mark is called a band. So it's basically a sharp band, and sometimes people just call this particular line the Shibian line for short. And on the Shibian line, you indicate what's going to be the shell that's going to be used for interpreting this particular shell script. If you add this particular Shibian line at the beginning of the script, let me save it. Now you don't have to type bash every time when you try to run this script. All you have to do is to type the name of the script. That's it. But this time it's not going to execute it. It's going to tell you permission denied. The reason it's telling you permission denied is that this is an ordinary text file. It doesn't have execution permission. So what you have to do is to modify its execution permission. Modify its permission. Let me do a long listing of this particular file. As you can see, it doesn't have X. It doesn't have the X permission. So what I'm going to do is I'm going to add X permission for this particular script. Now you do a long listing. You're going to see X here, X here, X here. So everyone can. Now if you call, then it's going to print out hello world without explicitly calling the shell itself in the command line. So, but the operating system is going to call the shell for you. It's going to call bash for you because the operating system can understand the Shibian line, and it will automatically invoke the correct shell for you to interpret this particular script. And don't forget about the /. Sometimes in some of the systems, so in a previous video I talked about the dot when we talked about how to navigate the file system. Dot and the dot. These two symbols. Dot represent the current working directory, the PWD. So for this particular exercise, my current directory is home poach and temp. So it's actually calling the script 1.sh in the current working directory. Sometimes this dot, the current working directory, is automatically added to the environment variable. That's called a path. We'll talk about the environment variables in a later video. In my case, it's sort of added. But this is actually not a very good practice, and it introduces security holes into your system. So it's not sort of a very good practice to put the dot, the current directory into your path environment variable. It's not a good idea. So in many systems today, this dot is not automatically added to your path environment variable. If that's the case, you'll have to tell the shell where this script is actually installed, or where the script is actually stored. You have to tell the operating system the location of this shell script. And so you have to sort of give it a path, give the operating system a path. Of course, you can do home pochain script 1 or temp script 1. It's going to have the exactly same effect. Or what you can do is to use the shorthand. It's going to give you exactly same. But in any case, you have to give it a complete path. This path can be absolute path or relative path. If it's a relative path, then it's just /script1.sh. So it's just inside of the current directory. And if you want to use the absolute path, you can do that, but it's more typing. Usually, if you are actually working in your current directory, then you can just type /script1.sh. Now let's try to add a few more lines into our script. I'm gonna do emacs nw script1.sh. So let's try to define some aliases in this script. I'm gonna do alias LA equals to, I'm defining a alias that's called LA, and it's gonna be equivalent to executing capital A L. So this is actually means a long listing of all the hidden files without the dot and the dot directories. So dash A, dash capital A means list all the hidden files except for dot and dot. And L is a long listing. And I'm going to define another alias LL equals to ls-l. That's a long listing. And then I'm going to define another alias that's called emacs. I'm going to alias emacs to emacs dash nw. So I don't have to type the dash nw option every time I use emacs. And let's save this script by holding down Control key and then XS, type XS, and then it's gonna save this script. And now let's exit the Emacs and try to execute this script. It's not gonna define the alias this time. But it's just gonna print out hello world. How do I know the alias is not sort of working? I can do type LL, for example. And then it's gonna tell me LL is not defined. If I do type LA, it's not defined. And then if I do type Emacs, and then it's gonna tell me Emacs is hashed. It's a user Bing Emacs. That was the original Emacs instead of the one that I defined using alias. So the reason is that these aliases are not working is because these aliases are defined during the execution of the script. So the execution of the script is carried out in a thing that's called a subshell. It's not in the shell itself. So these aliases becomes undefined as soon as the shell script finishes executing. So if you would like to keep the result of the script in the current working shell, you'll have to use a third way of executing a shell script. Source is basically a command, and you can just source and then followed by the script that you are trying to execute. And it's still going to sort of execute the script. It's going to execute script1.sh and print out a hello world. But this time, all the aliases defined in this script becomes available. So now if I type Emacs, it's going to tell me Emacs is aliased to Emacs-nw. If I do type LL, it's going to tell me it's aliased to LSL. And I can use LL to list my current directory, to do a long listing of everything that's in my current directory. And I can do an LA dot. It's going to list all the hidden files in my home directory. So that's a third way of executing a script, and it has different effects from the other two. So basically, that's how you can write a script, put stuff into a script, and how you can execute a script in different ways. Now let's look at what kind of variables are available, or what kind of variables you can define inside of a shell script. The first set of variables is called the environment variables. This set of variables is sort of a in-memory variables that are assigned and loaded by default when you log in. And this set of variables are known as the environment variables, and it can be used by different commands to get information about your running environment, such as the system you are running on, your home directory, the shell you are using, that kind of thing. And you can get a list of all the environment variables that's defined in your environment by using the command env. Because it's going to print out a quite long list for my current execution, I'm going to pipe it through more so you can see the details instead of looking at So for example, it defines a variable that's called shell. That's an environment variable, and it's equals to bin bash. So the bash is basically a command that's underneath root bin, and my shell environment variable equals to that bash. So I'm using a bash as my default shell. It also defines these lines. These lines were added by myself in my startup script. I will show you my startup script a little bit later. And then there's an environment variable that's called user, and that's my username. Some other lines, LD library path. It's basically a path for you to find shared libraries. And then path, this path environment variable, we talked about it just a little bit. We talked about this particular environment variable before. And this environment variable actually specifies the default location for storing those executable files. So if you type a command in your after your prompt in your terminal, and you didn't specify the path to that particular executable, then the operating system is going to look into this path environment variable, and it's going to search through every path that's listed in here and look for the command that you have typed. And then it's going to execute the first occurrence of that executable in any of the files, in those files, in those directories. So suppose your executable is not stored in any of those paths defining the path environment variable. Then it's going to print. The operating system is going to tell you it cannot find that executable. So the path environment variable defines a default search path for locating a certain command. Some other names, I think pwd is an environment variable that tells me where I am in my current directory structures. And anything else that's kind of interesting, it's the home environment variable. We have used this one before, right? I've used this home environment variable. It's basically a variable that stores my home directory, a string to the directory of my to my home, the path name of my home directory, basically. And there are also some other commands. So if you would like to take a look at, that's how you actually define. That's how these syntaxes are actually how you actually define an environment variable. And if you would like to take a look at the content of an environment variable, you can echo. You can use echo and then $sign, and then followed by the name of the variable, the environment variable, suppose path. And you have to be careful about the case. And if you do echo, it's not going to display anything because it's case sensitive, and you have to sort of pay attention to the case. So some of the environment variables are actually defined by the system itself when you log in. And then there is a certain set of environment variables that you can define by yourself. And those environment variables are in your home directory. If you do lsa, you're going to see a file that's called .bshrc. And this .bshrc is a special kind of shell script, and you can take a look at its content. First of all, it doesn't have a shebang line. It doesn't have a shebang line. The reason it doesn't have a shebang line is because this shell script is not sort of executed by the user in the terminal. It's automatically executed every time you log in by the system. So that's why it doesn't have a shebang line. But it's gonna be executed automatically by the login system. And inside of this script, you can define lots of things. So first of all, it's actually sourcing the global definition. So there is a template BASHRC file inside of the /etc directory. The /etc directory also basically installs some of the system-wide configuration files, and there's a bshrc template inside of it. And this dot means just I want to source it, so it's equivalent to typing the source and then this thing, this path. And then it's gonna define a set of aliases. For example, rm is aliased to rm-i cp, defined as cp-i, and a bunch of aliases. And then export allows you to define your own environment variables. So alias is one command to introduce an alias, and then export is a command that allows you to export or define environment variables. So here I'm actually defining a sequence of my own environment variables, which are basically the name of some remote computers I often use. Export some more. For example, I'm actually modifying the definition of the path. So the system itself is going to have a default definition of path. And here I am actually taking the value stored in the system-defined path and added my own path to it. And you can append new path to the path environment variable by using the colon. So basically, colon is a concatenation of the existing path defined by the system with something that I added by myself. And then the left-hand side of the equal sign defines a new string character that's separated by colon. And then I assign that character string back to path. And then I export it to the environment. So I have a new path environment variable that's defined by myself or modified by myself. Some additional, one more alias and some additional, I'm changing the path environment variable. Furthermore, I'm adding new path to the path environment variable actually. To path environment variable. So that's a special kind of a shell script. And the system actually executes the .bshrc file by doing source.bshrc. So all the alias that's defining it are going to have effect after the script finishes executing. So that's called environment variables, and those environment variables are available to you when you write your own script. Suppose we get back to the script 1.sh and we add another line. Let's add another line. Let's just echo path. Here I'm trying to take a look at the content of my path environment variable. So if you actually source it, I'm going to comment out. Suppose you want to comment out a certain line in your script, you add the pound sign or sharp sign in front of the line, and then it's going to comment out those lines. Now if I execute script 1.sh, then it's going to echo hello world, and then it's also going to echo my path, my entire path environment variable. I have some of them were added by the system. For example, these directories were automatically added by the system itself. And then some of those, for example, some of those later directories, those directories were added by myself in my .bshrc file. So as you can see, it's you can use environment variables. You can also define environment variables in your own shell script. A second type of variables are called built-in variables. Those are variables that's available to the shell scripting language, and you can use those to make it easier for you to write shell scripts. Now let's try to write another shell script. Let's call it script 2.sh. Again, I'm going to use a shebang line. The shebang line is basically the complete path, the absolute path to my shell interpreter. That's my bash. That's the name of my shell. This time I'm going to echo hello, and then followed by the name of the user who's actually typing this particular command. So how am I going to do that? I'm going to ask the user to put some command line inputs to my shell script. And those command line inputs can have any kind of content, but it's going to be separated by spaces. And the first command line input is going to be denoted as $1. So let's see what's going to happen here. Again, don't forget to change the permission of your script. Now if I do script 2.sh, it's just going to display hello with nothing appended after it. But if I give it some kind of text string, any text string, it's going to have this thing behind it. So whatever I type as the first command line input to the script, it's going to be displayed after the hello. So that's sort of the effect of putting this particular variable, or printing out this particular variable, using this particular variable, this particular variable. So you can imagine what's going to be the second command line input, and you can use the second command line input just like using the first one, except that changing 1 to 2, and you can put 3 here or whatever. It doesn't really matter how many command line input you have. You can access the content of all those command line inputs, or what they call the positional arguments, using this particular way. These variables cannot be changed. It's built-in, so it means that inside of this script you cannot change those variables values. You can access their values, but you cannot make any changes to it. So suppose I'm going to print out my first and last name. So I can just execute it like this. But if I neglect my last name, and then it's just going to print out the first one, because the second command line input does not exist, so it's not printing out anything for the last name part. So these are what we call the positional arguments, and you can access their values by using a $sign followed by a number. So it starts from 1. But what about 0? Do we have a command line argument that starts with a 0? Does it have a variable that's called a 0? Let's see what's actually 0 actually represents. So it's actually printing hello PoChain from. This one is actually $0. So the $0 actually is actually representing the name of the script itself. So you do have a positional argument that starts with 0. So $0 is actually a representation of the command itself, or your script, or the name of your script. Now, suppose I don't really know how many characters are going to be, how many arguments are going to be entered, but I would like to access the complete command line input as one single string. How am I going to do that? I can do that by using $star. A $star represents the complete command line input. Doesn't matter how many arguments you have, it's going to concatenate into this single string. And this single string is represented in the script as a $star. So now I can put whatever, if I just put like a 1 command line input, and then it's just gonna print out print out my first name. If I do this, it's gonna print out both arguments, and these two arguments are actually separated by a space. And if I want to do 3 parameters, then it's going to print out 3 parameters. So it doesn't really matter how many parameters you are going to put in there. It's going to be treated just as one single string, and then it's going to print out the entire string for you. So how do you actually examine the number of positional arguments you actually have? There's also a built-in variable that's called, that's this dollar sign with the pound sign. And then this actually is a built-in variable that contains the total number of command line inputs, or the number of arguments or positional arguments. So what I can say is that total number of positional arguments followed by dollar sign pound. Now if I execute this particular command, it's going to tell me total number of positional arguments 3. That's 1, 2, and 3. It doesn't count the name of the script as the command line input, command line or positional arguments. So you can access those positional arguments by using a dollar sign followed by a number, 1, 2, 3, any kind of a number. And you can access the script, the name of the script itself, using dollar sign 0. You can access the complete command line input as a single string using a dollar sign star. And then you can access the total number of positional arguments, using dollar sign pound. So these are the built-in variables, some of the built-in variables that are useful for writing shell scripts. Now let's look at a third type of variables that's called user variables. So those user variables can be defined by the users and can be sort of used in the script. Let's write a third script. Let's call script 3.sh. Again, I'm gonna use a shebang line bing bash, and then I'm gonna define a variable. How do you actually define a variable using bash, right? Let's call it var1. So that's the name of my variable, and then followed by the equal to sign, without any space before after the equal sign. It has to be sort of no space at all. Let's just call it ABC def. It's just a 2-character string separated by a space. So var1 is going to have a value that's ABC space def. So that's the way that you define a variable. It can be anything. You can also assign a number to it. Suppose I give it like a number to it. Again, no space in front of or after the equal sign, no space. And if you do that, you can, once you have defined a variable, you can use it. For example, I'm going to use it in the echo command. You use a variable again by appending the variable name with a dollar sign, and then now you can save it, change its permission, and then execute it. And then it's going to echo this particular sequence to you. You can define new variables using existing variables that you have already defined. Suppose I define var3 equals to var1 space followed by space ghi. Then here you are actually using var1, the value that you have already defined at the beginning. You can use a variable after it has been defined. So if I delete this line, suppose I comment out this line, then this line is not going to work because VAR1 hasn't been defined yet. If you define the VAR1 after VAR3, suppose you move this line to the end of the file, it's not going to work either, because at this line VAR1 hasn't been defined yet, and you cannot use the values stored in VAR1 yet. So you have to make sure that when you use a variable to define new variables, this old variable has to exist, and this is actually the correct way of using a existing variable. And you can do echo VAR3 now. Now it's gonna echo ABCDEF that was stored in VAR1, and then GHI was some new stuff added to VAR3, and now the VAR3 has a value that's ABCDEF space DEF space GHI. Now let's assume that we would like to have a character string that's with exactly this particular sequence of characters. Instead of just treating VAR1 as a variable, you actually would like to have a string that's called $sign VAR1 and then GHI. Let's say VAR4 equals 2. What I would like to have in VAR4 is actually the sequence VAR1 space GHI. But if we actually include those characters as in a period of double quotation signs, the shell is going to interpret this as a variable name. But that's not what you wanted. You want the string $var1 actually. So how you can achieve that? You can change the double quotation to single quotation. And then if you actually echo var4, you're going to see that var4 will have a string that's different from var3. So this line is var3, this line is var4. And as you can see, var4 actually is treating this $sign var1 as a sequence of character strings instead of as a variable. So you can use the single quotation to escape this particular interpretation by the shell. There's also another way, a second way, for you to escape the default interpretation of the $sign. That's by using the backslash. Here I'm still using the double quotation sign, but instead of just using a $sign var1, I preceded the $sign with a backslash. The backslash is called an escape symbol. So if you do not use the backslash, var1 is the $sign var1 is going to be interpreted or expanded using the value that's stored in the variable var1. That's sort of the default shell behavior. But if you actually precede the $sign with the backslash, it's going to escape the default interpretation and won't expand the $sign var1 using the variable name, using the content stored in var1. And it's going to give you exactly the same effect as var4. This is var4, and now this is var5 by using an escape character. That's the backslash. Now let's look at another capability that's introduced by the backtick. So the backtick is something that's located on the right hand side, on the upper left hand side of your keyboard. That's right beneath the escape key. It's called a backtick. It looks like the single quotation sign, but the direction of it is just the opposite of the single quotation. And this pair of backticks is called a command substitution. So you can actually assign the result of executing a certain command to a certain variable. Let's define this variable as var6, and I'm going to count the total number of lines inside of my current script using the wc-l command. So this wc-l command, we looked at this command before. If you are not familiar with it, you can pull out its main page, the main wc. It's going to tell you print new line, word, and byte count for each file. So I'm using the -l option. -l option is here. Lines. It's going to print the new line counts. One new line count is equivalent to one line in a text file. So this is going to assign the output of wc-l followed by script3.sh. I'm counting the total number of lines in my current script to var6. So the backticks is called command substitution. And if I do echo var6, it's going to print out the content of the variable var6. Then it's telling me the script3 has 18 lines. So if I do wc-l script3.sh, it's going to print out exactly the same thing as the content stored in var6. So suppose you don't want to really print out the file name, you just want to store the number. You just want to store the number inside of var6. How you can actually do that, right? It's actually quite simple. So here you are actually using script3.sh as a command line input to the wc-l command. So what you can do is to change it from command line input to a redirection of the standard input. So when we talk about the redirection, we talk about this smaller than sign and larger than sign. So larger than sign is a redirection from the standard output to a particular file. Here you actually using the redirection from the standard input to a file. You're changing this. So wc-l by default it can actually read standard input. So effectively you're actually calling wc-l using its capability for reading standard input without specifying a file. But the standard input has been switched, has been redirected. So standard input has been replaced by this file. So you're basically using this particular file as the standard input, and you're calling wc-l by using standard input as its input. And this way, var6 is going to have just number in it. It's 18. The backtick symbol allows you to build actually quite complicated expressions into variables actually. So let's try some arithmetic calculations, for example. Suppose I would like to define another variable that equals to, this time I'm going to use a backtick pair, but with another command that's called expr. I'm going to use the variable that's the number that's defining variable 6 plus, I'm going to give it integers at like 10, and then I'm going to echo var7. So here I'm actually using the command line tool that's called expr, followed by the var6. I'm actually taking out the value in var6. I'm extracting the value from var6, which is supposed to be whatever number. For now, how many lines do I have? I have 21 lines. So 21 lines plus 10, it's supposed to be 32. 31. It's supposed to be 31. And then that's going to be expr actually allows me to carry out that arithmetic calculation and then assign the result back to var7. So if you have used expr expression, haven't used the expr expression before, you can do main expr in the command line. And then it's going to show you how to use the expr command. It's called evaluate expressions, and it allows you to evaluate these kind of logical expressions. These are all logical expressions, And then it also allows you to compare arguments, comparison expressions, and then some arithmetic calculations. This is a plus, add two numbers together, subtract, multiply, divide. This is modulo, I think it's a, and so EXPR allows you to do some arithmetic calculations. Now if I execute expression 3.sh, it's going to give me 31. So the variable 7, VAR7, actually has a value of 31 in it. So how about these are two integers, adding two integers together. One thing that you have to sort of pay special attention to is the plus. You must keep a space before and after plus. Otherwise, it's going to give you the wrong result. Suppose I remove the space. And let's see what's going to happen. It's going to print out the text string 21 plus 10 instead of adding the two numbers together. Maybe that's what you wanted. Maybe that's exactly what you wanted. You want this character string. But if you actually want to carry out the summation, then you must keep a space before and after the plus sign. Must do that. Suppose you would like to do floating point calculations, for example. Here I have a floating point number that's defining VAR2. That's 3.1415926. That's a floating point number. If you still do EXPR, it's not going to work. Suppose I do a backtick EXPR and VAR6 times, for example, VAR2. Still backtick. If I echo VAR8, then it's telling me syntax error. So this time it's not going to work using EXPR. But luckily we have another command that's called BC. If you haven't used the BC before, it's a calculator with arbitrary precision calculator language. It's called BC, an arbitrary precision calculator language. And it allows you to do floating point calculations. Here is a multiplication or product of. So we can actually change our script to use BC. So how do we actually change it? We change it this way. I'm going to echo this, multiply this, and then pipe it to BC. So here I'm actually using a pipe vertical bar. So I'm echoing VAR6 multiply VAR2. VAR6 is going to be whatever number that's stored in this variable. And then VAR2 is going to be that floating point number. And then the result of the echo is just printing out that string. That's the number in VAR6 times the floating point number in VAR2. And then it's going to be the output of the echo is going to become the input to BC. And BC is going to calculate the result of the multiplication and then assign it back. This backtick pair is going to assign the result back to VAR8. And then let's see what's going to happen. So now it's actually multiplying the number that's in VAR2 with the number that's in VAR6. The number in VAR6 is 24. And if you have a calculator, you can verify that this number is exactly 24 times that 3.1415926. It must be. So that's how you can actually use BC to calculate some floating point arithmetics. One thing that you have to pay special attention to when using the BC command is that you cannot put a space before and after the operand, the multiplication symbol. If you do that, suppose you put a space before and after it, it's not going to give you the correct result. It's going to give you illegal character, this kind of thing. So you have to sort of remove any kind of space between or after uh, before after the, the, the arithmetic operand. In a shell script, you can also define and use array variables. Let's try to write another script, for.sh. So let's use a Shebang line. So I'm going to define array variable. Let's call it AVAR1. That's the name of the array variable. Followed by equal to sign, no space, either before or after the equal sign. And then followed by a parenthesis. So you can list all the array elements inside of these parentheses. So I'm going to give some numbers, uh, some arbitrary numbers. And then so you can sort of see different elements are separated using a space. It can be numbers or character strings. It can be positive or negative numbers, or it can be integers or floating points. So that's how you can actually define a array element, array variable. So how do you actually retrieve elements or access the elements stored in an array variable? You do that still by using the dollar sign, but now you have to follow the dollar sign with a pair of curly braces, and then followed by the name of the variable, the array variable. So in this case, AVAR1, AVAR1, and then followed by AVAR1 has to be followed by a pair of square brackets, and then that's the index. The index is just a number that you put in there. And in the shell script, the index is starting from 0, so it's 0-based indexing. In this case, it's going to print out 2.3. So the syntax is like this. You still use the dollar sign, but the stuff that's following dollar sign is the name of the variable. But for this particular case, the name of the variable is one element inside of this array. So how do you actually define the array name? It's how do you actually define the element, the name of the element? It's basically the array name followed by a square parenthesis, and then you put the index of the element inside of the square parenthesis, square brackets. And let's change its position, change its permission, and then just execute it. And it's gonna print out 2.3. That's the first element, and the index is 0. And what about the last element? Let's echo the last element. So 0, 1, 2, 3. That's 3. It's actually a text string, actually. So text string. So that's how you can actually access the elements inside of an array. Suppose you would like to print out the entire array. What you can do is still, but inside of the square brackets, you put either a star or put the symbol at. These two lines are going to print out the entire array. You can put either a star, it's just like a wildcard. You want all elements, so it's just a star. Or you can replace the star with the at symbol. These two lines are both going to print out the entire array. The entire array. Let's define another variable. This time, let's put all strings into it. Let's use some popular Linux distributions. For example, Red Hat, and then open SUSE, and then Ubuntu, and then Gentoo. You can notice that if I have a space in the text string, I'm using the double quotation sign to enclose this space separated words. This is just one word, but you can also enclose it between a double quotation sign. It's gonna have exactly the same effect. This is just one word. This is another word, but I'm not enclosing it in a double quotation sign. This is another word. So in this case, you can still access AVER2. Suppose I want to access the first element. Want to access this is 0, 1, 2. This is second. This third element, so it's actually second. And then I also want to print out the entire array by itself. Or just use a star. So I made a mistake here. So red hat, that's first element, the third element, and then 1, 2, 3, 4, 5. So this one actually has 5 elements in it. One thing that people often try to do is to find out the length of an array, how many elements are in the particular array. And inside the shell script, there's a quite easy way for doing that. So if you would like to access the length of the array, for example, I would like to access the length of AVER2. That's 1, 2, 3, 4. It's actually 4 elements in it. So what I can do is to, again, dollar sign, a pair of curly braces, and then followed by the hash, the pound sign, AVER2. And inside of this square brackets, I put the star, the wildcard in it. So basically, I'm actually accessing this thing, the whole thing that's inside of the curly braces, as some kind of variable name. And what's actually the variable name? It's the number, and then followed by the name of the array with its index specified using the wildcard. And then it's going to print out the length of the array. Now it's 4. 1, 2, 3, 4. Of course, you can also replace the star with the @ and it's going to give you exactly the same result. That's also 4. It's exactly the same, actually. And when we talked about the command line inputs or the positional arguments, we looked at how to actually find out the total number of positional arguments. So that's script 2.sh that we have looked at before in a previous video. So in this particular command, total number of positional arguments was represented using $sign and then just a hash. And you can sort of see the similarity here. The total number of elements in a particular array is $sign, still hash, but what's actually sort of this you have to sort of use the name of the array and also the total number of elements in the length of array following the hash or following the pound sign, and then enclose everything between a curly braces. So the shell script can understand what exactly is the number that you are actually looking for.